Let's think about your brain for a second. We often hear about the left brain versus the right brain, as if they're in a constant battle. But what if that's not the whole story? What if your brain is less like a competition and more like a single incredibly complex orchestra? Every thought, every feeling, every dream, that's the music. So today, let's listen in on the amazing symphony your brain plays all day long.
I mean, seriously, have you ever just stopped and wondered what is actually going on up there? From the moment your alarm goes off to the deepest moments of sleep, your brain is running the show, constantly shifting and adapting. So what does that actually sound like? We're about to follow a day in the life of your brain to find out.
So here's our roadmap. We're going to start with the very basics, the brain's electrical music. Then we'll see how it juggles focusing on the outside world versus our inner thoughts. We'll even see how it learns a new skill. From there, we'll look at how it switches gears, how it rests, and finally, we'll dive into the wild world of dreams. Let's get started.
To understand the symphony, you first have to meet the instruments, right? Well, the brain's music is made of electrical signals we call brainwaves. These are the fundamental notes, the building blocks for the entire composition of your conscious life.
Check this out. This is the whole family of brainwaves. There are 5 main types, and each one has its own tempo, its own rhythm. You've got these super fast gamma waves for when you're really concentrating, and then way down at the other end, you have the slow, deep delta waves for dreamless sleep. For most of our waking day, though, the main players in our orchestra are gamma, beta, and alpha waves.
Let's talk about alpha waves for a second. Think of these as the sound of the orchestra tuning up right before the show starts. You know that low hum? That's what your brain is doing when you're awake, but totally relaxed. Maybe sitting quietly with your eyes closed. It's not sleeping. It's calm. It's idling. It's just...
All right, the day's begun, and the symphony is in full swing. One of the most amazing things our brain does is manage our attention. It seamlessly shifts our focus between the worlds happening around us and the rich, complex world happening inside our own heads.
Now, this isn't a competition. It's not a tug-of-war for control. It's more like 2 different sections of the orchestra that have learned to play in perfect harmony. Your brain has these 2 primary, totally complementary modes that it uses to navigate reality.
This is a perfect way to picture it. When you're just chilling out, daydreaming, or thinking about something that happened yesterday, that's your default mode network, or DMN, kicking in. That's your inner world. But the second you need to focus on a task, like answering an email, boom, the task-positive networks take over. They work in this beautiful dance. One quiets down as the other gets louder, letting you switch focus in an instant.
So how does the brain actually choose where to focus? Well, it uses a process called top-down control. And this is where our alpha waves, that calm, idling rhythm we talked about, play a really surprising role. They're not just for relaxing. They act like a filter, kind of like a neural windshield wiper that actively clears away distractions so you can concentrate on what's important.
Here's a perfect example. Let's say you're trying to remember a phone number. To do that, your brain actually ramps up the power of alpha waves in certain areas. This actively quiets down the parts of your brain that are listening to the outside world, creating this silent mental space for you to dig up that memory. It's like the conductor telling the percussion section to hush for a moment so we can all hear the violin solo. It's beautiful.
Okay, so how does this play out in the real world? Let's look at what happens when the orchestra has to learn a brand new piece of music. When we try to learn a new physical skill.
You know the feeling. We've all been there, right? Whether it's learning a chord on a guitar, trying a new dance move, or even just learning to type, your first attempts are so clunky and stiff. You have to think about every single tiny movement.
But then you keep practicing, and after a while, something just clicks. The movements become smooth, fluid, almost automatic. You don't even have to think about it anymore. So what's actually changing in the brain to make that happen?
So, in its default state for everyday movements, the brain uses something called phase amplitude coupling, or PAC. And that sounds technical, but think of it like this. You have these steady beta waves that set a constant, reliable rhythm. That's the status quo. Then you have the faster gamma waves, which are the actual do-this signals for your muscles. In PAC, the gamma waves are locked to the beta rhythm. It keeps things stable and automatic.
But to get really good, to achieve that fluid mastery, the brain does something amazing. It performs PAC decoupling. It intentionally breaks that rigid link between the beta rhythm and the gamma action signals. This frees up your motor system, letting it become way more flexible and responsive. It's literally the difference between a beginner who's rigidly following the sheet music and a master who can improvise a beautiful solo.
So, we have all these different states and modes, focusing inward, focusing outward, learning new things.
But who's actually conducting this whole orchestra? What part of the brain stands at the podium and guides all these incredible shifts?
Meet the conductor, the medial prefrontal cortex, or MPFC for short. The MPFC has this really cool job. It's a core part of our inner self network, the DMN, but it's also wired directly into the networks that pay attention to the outside world. This unique position makes it the perfect hub for deciding where your focus goes, for sorting out any conflicts between an inner thought and an outer demand, and for directing the flow of the entire symphony.
Okay, after a long day of performing, even the best orchestra needs to rest. But for the brain, rest doesn't mean silence. Oh no. It's a time for system maintenance, for memory consolidation, and for a completely different kind of music to start playing.
As you start to fall asleep, the long-range chatter between different parts of your brain quiets down. The activity becomes much more local. And a key player here is the thalamus. That's the brain's main sensory relay station. It basically turns down the volume knob on the outside world, allowing your brain to disconnect and focus on all its internal repair work.
This chart gives us a fantastic snapshot of the different stages of sleep. You can see how the brain's signals change as the night goes on. In deep non-REM sleep, your brain is busy processing memories. Then, as you move toward REM sleep, you start to see these signals called PGO waves pop up. And by the time you hit REM sleep, these PGO waves are firing in frequent bursts, and your brain is getting the stage ready for the dream cinema to begin.
Which brings us to the most mysterious, most fascinating part of the night, dreaming. During REM sleep, our brain becomes its own movie director, writer, and audience all at once, creating these vivid, immersive worlds out of thin air. Let's pull back the curtain and see how it works.
It's a surprisingly organized process. It starts with those PGO waves we just talked about, these sharp electrical bursts that originate deep in the brainstem. These signals then travel up through the thalamus, our trusty relay station, and they arrive at the occipital lobe, which is the visual cortex at the back of your head. And just like that, with no light coming from your eyes at all, your brain starts generating the rich visual imagery of your dreams. It's literally directing its own movie, every single night.
And of course, your brain has this brilliant safety feature built in. While your mind is off flying or running through these incredible dream worlds, a circuit in your brainstem sends out a signal that temporarily paralyzes your major muscles. This state is called atonia, and it's what keeps you safely tucked in bed instead of trying to literally act out your dream. Pretty smart, huh?
So, from the first electrical hum when you wake up to the final dream of the night, your brain is operating as this single, beautifully integrated orchestra. It's not a collection of parts fighting for control, but a holistic, dynamic, and interconnected marvel. Thank you for watching.